10, 20, 30.
That's all right. That's all right. That's what IXL does, right? That's how they get you. I know. I went to Walmart and I got the $1 bins. You got the good bag of Sour Patch Kids.
I have one.
You guys don't. You
So,
Good, that's great.
kind of job.
yes.
Also, blood quit, so.
All right, so 6.3. Today we're really not doing anything we haven't seen before. We're going to factor polynomials, and then we're just going to go that extra step and actually solve them. So we're going to take some of those like grouping questions, like the ones that you just did on IXL, but now we're going to go a step further and say, okay, I've got to set each of my factors equal to 0 and solve. Sometimes we get nice integer answers. Sometimes we will get imaginary solutions, which at this point, for this unit, you're allowed to say that it's just imaginary. I'm not going to make you kind of simplify all the way down. We've done that before. And sometimes you will get square roots. And I will make you simplify those square roots so that we know exactly what they look like. Let's start up with a warm-up, though. Go ahead and factor this. It's a quadratic, so really we just need to reverse FOIL. I highly recommend looking for a GCF first before you start it. Whether you use grouping or guess and check, completely up to you. Once you've factored it, make sure you look at the directions to find the zeros. Make sure you do that extra step of finding those zeros as well. All right, let's go over this. Anybody want to shout out their answer or explain how they did it for the class? Kevin, you want to go?
I have it factored, but I haven't solved for the x's yet.
Okay.
Okay.
So what was the first step that you took?
First step was I got a GCF by taking 3 out of all of them, so I ended up with 3 parentheses 2x squared minus 5x minus 3.
Perfect. Now, how have you been solving? Are you using grouping or guess and check with these?
I kind of did guess and check, and I just ran like them all through my head real quick. So
Okay.
I got 3 parentheses 2x plus 2 parentheses x minus 3.
2x plus
2. 3. 1. Oh, yeah.
So, right, if we're doing guess and check, which is fine, right? We've got 2x and x, so yes, those are up front. And then in the back, it has to be 3 and 1, because those are the factor pairs of 3. So I just have to figure out kind of where to put them. Put the 3 over here, the 1 over here. This negative sign in front of the 3 tells me that my factor pairs are going to have different signs. So I just have to figure out where to put the negative and where to put the positive. And I can double check, right, by foiling, negative 6x, positive 1x. It's a nice little review of guess and check. So I get 3 times the quantity 2x plus 1, and then x minus 3. And then in order to find the zeros, I set each of those factor pairs equal to 0, and I solve. So I get x equals 3, x equals negative 1/2. Do I have to set that 3 equal to 0?
Nope.
Nope, doesn't make sense. Now, if this were a 3x, then yes, I would have a third 0 as part of my solution, but because it's just a 3, that is how we factor down. Good job. As I was looking around, you're doing a good job, okay? But just know, I'm going to integrate some of these type questions with all the new factoring that we've learned in this unit. So don't be surprised if you see a question similar to this on your test. This is still part of a factoring polynomial standard that we're trying to get to. Okay, so today's lesson is really us just doing 6 examples together, and then I do have one word problem, but it really is just us doing some examples together, making sure we've got this down, and going that extra step of setting each of our factors equal to 0 and solving. So when I look at letter A, how am I going to factor this one? Is it cubic? Yes. Can I use the sum or difference of perfect cubes?
No.
No. So what I'm going to try to do, right, I've got 4 terms, 1, 2, 3, 4. I'm going to solve it by grouping. So just like one of those IXLs we just did. So in my first example here, I take out the m squared. I'm left with m plus 6. In the second binomial here, I take out a negative 4 because I need those to match. I need to make sure I get an m plus 6 when I factor out those GCFs. I take out my common term, which is the m plus 6, and then my other factor that's left over is m squared minus 4. Notice on all of these problems it's set equal to 0 before we were just factoring. Now we actually have to find the solutions. Am I done factoring?
No.
Gotta keep going. Alright, this is the sum difference, or the sum of perfect, or difference of perfect squares, so I gotta keep going. All of this we have seen before, so today really the final step is you just set each one of these equal to 0 and you solve. So I set m plus 6 equal to 0, I get m equals negative 6, m equals negative 2, m equals positive 2. Questions on that? That's all we're doing today. Yes. Today really is a little bit of a catch-up review day. I always kind of judge how we're doing, but you guys did great on your
So it's pretty
ISS.
much the same thing, except now we're solving for
Now
the-
we're solving. That's
Okay.
really the only big leap. That is really the only big leap. So how many x-intercepts does this function have? How many real x-intercepts does this function have?
3.
3, and they are listed right here. Okay, remember, that is all we're solving for as we go through these examples. We're just solving for the x-intercepts. All right, looking at letter B, do I have a GCF in there I can take out?
3a cubed.
3a cubed, that is right. And when I do that, I'm left with a squared minus 25. Can I keep factoring? Yes, I can. So I get a minus 5, a plus 5. I have now factored all the way down, so my final step is just to set each of these factors equal to 0 and solve. Now in this case, I do have to consider this factor. What does a have to be? 0. Remember, 0 can still be an x-intercept. Don't automatically assume that we can throw something like that out. So in this case, what type of function is this? What type of polynomial? Does everybody remember from section 1?
No. It's a quintic.
Quintic, that is right. It is a quintic function. So I could have up to 5 x-intercepts. Real, but I only have 3. Right? My fundamental theorem of algebra said I could have 5 x-intercepts, but you really only have 3. All right, let's look at letter C. What's our GCF there?
4w cubed.
Or w cubed. So I'm left with w squared minus 21. Am I done factoring?
No.
You say no, Peyton says yes. Is 21 a perfect square?
No.
I cannot factor this any further. Okay? So at this point, I am done factoring. I can set each of my factors equal to 0 and solve. So I set 4w cubed equal to 0. I get w equals 0. There's one of my x-intercepts. And then over here, I also have to set this equal to 0.
Fun.
How do I solve it?
Add 21 to both sides.
Yes. Sorry. So excited. Once I add 21 to both sides, I take the square root of both, right? Whatever I do to one side of my equal sign, I have to do to the other. And don't forget, it's coming back to haunt us, positive, negative. So we have 3 real x-intercepts. One is positive square root of 21, one is negative square root of 21, and the other one is 0.
Do you get to write all of them separately, or can you just have plus?
I'm fine with plus minus. Yep. You guys want to try letter D on your own? Go ahead, try letter D.
I have been.
Remember, once you're done factoring, set those factors equal to 0, get all the solutions. All right, my first step, I'm going to take out my GCF. Then I see I've really just got a quadratic expression here that I'm going to reverse FOIL. So whether you're doing guess and check or you're doing that grouping method, I'm going to have my 2x and my x. Plus sign tells me the 5 and the 1 are both going to be positive, so I just have to make sure I put them in the right spot. And I FOIL through to double check. I got 2x, 5x, those add up to 7x, perfect. I set each one of these equal to 0. So I get x equals 0, x equals negative 5 halves, x equals negative 1. Questions on that? Did I go too fast through finding the intercepts? We're all right with that? Doing okay? All right. I want us to do letter E together because we're going to start out a little bit differently and we're going to get imaginary solutions on this. So I want to make sure we do an example together like that. So the first thing I need to do is I need to have all 4 of my terms on one side. So I'm going to add 36 to both sides. So I get 5x cubed plus 15x squared plus 12x plus 36 equals 0. Now I've got a cubic and I have 4 terms. So that tells me with my 4 terms, I'm going to do our grouping approach. Group my first 2 and my last 2. For my first 2 terms, I take out my common factor, which is 5x squared. I'm left with x plus 3. And in the second half, my common factor is 12. Also left with x plus 3. I take out the common factor of x plus 3. And then what is left over, I've got 5x squared plus 12. That is the other factor. So of course, right, the first thing you should do is ask yourself, can I keep factoring this down? I cannot. This is done factoring. So now that we're done factoring, let's set each of these equal to 0 and solve. So in my first example, right, x plus 3 equals 0, I get x equals negative 3. That's pretty easy. But on this one, I've got 5x squared plus 12 equals 0. I've got to subtract 12 from both sides, and then divide by 5. So I get x squared is equal to negative 12 fifths. When I take the square root of both sides, I wind up with a negative under the radical. Because of that, right, these are imaginary solutions. There are two of them, right, because I have to consider plus and minus, but I have two imaginary solutions. So at this point, you can just say two imaginary solutions and go about your day. I'm not going to make you simplify those down any further than that. So here's kind of an example is, even with this factoring, right, I have a cubic. A cubic, by the fundamental theorem of algebra, says it could have 3 real x-intercepts. But it needs to have 3. We found them, it's just 2 of them happen to be imaginary and only 1 of them is real. So if we were to graph this in Desmos, it would only hit the x-axis in one place. Okay? Go ahead, try letter F on your own. Make sure you put everything on one side of the equal sign before you start your factoring.
So once we get to x equals positive or negative square root of negative 12 over 5, we're done.
Yep, you can just say two imaginary solutions. Yep. Another grouping question. Alright, so as I group, right, in the front I take out the x squared, in the back I take out a negative 3, I'm left with x plus 6 for both of those. So now I set each of my factors equal to 0 and solve. X equals negative 6. And x equals positive or negative the square root of 3. So these are real solutions, they just happen to be pretty ugly. Okay? If we were to graph this, we would see an x-intercept at square root of 3 and negative square root of 3, but we would see the decimal. Right? It would be hard to know exactly where it is unless we solved it algebraically.
If it's x squared minus 3 equals 0, how does it go from
You add 3 to
negative
both
3?
sides.
What?
You add 3 to both sides to solve for the x squared. Then you take the square root. Sorry, I did not show that step. I shortcutted. Other questions on this? All right, so we've got a word problem. The word problem, you will see a similar type word problem on your exam. Is it real world? I don't think so. But what it does is it's combining stuff from 6.1, which is multiplying polynomials, 6.2, factoring, and then 6.3, solving. So it does have all of the pieces of everything we've done so far. It's written as a real world example, but let's be honest, it's a mathy type example. Because we're in 1980, archaeologists decided to measure things in terms of X. Not sure if I think that's really true or not, but they have, okay? So they found a hydraulic concrete block. It is a rectangular prism. Right, so we've got kind of this rectangular prism down here. We can't see the whole thing, but we're supposed to assume that the dimensions allow for 90-degree angles and all that fun stuff. It has a volume of 330 cubic yards. The block's dimensions are x yards high by 13x minus 11 yards long by 13x minus 15 yards wide. What is the height, which the height is x, right? It's x yards high. So how do we find the volume of a right rectangular prism? Carter.
Width times height.
Length times width times height. Carter sees where I'm going. He's very excited for this word problem. Right? We're just doing length times width times height. Which unfortunately means I've got a lot of x's and stuff to multiply together. Now we know the volume is 330. So I can say 330 is equal to the length, the width, and the height. So what am I going to do first? I recommend the foiling part. I recommend getting that foiling part out of the way. Okay? It's okay to sneeze in your mask. It's okay. All right, so I'm going to foil these two things together nice and slow so that I don't make an arithmetic error as I go along the way. And I'm going to pull up my sheet here.
You go. Your mask.
Right, so I'm going to multiply my first, my outers, my inners, and my last together. And then I have some common terms in there that I need to combine together. Now I'm going to distribute this x through to all three of these terms, right? I do think it's better to kind of handle the foiling first and then multiply through. So all it really does is increase my exponents by 1 on all of my terms. So we're getting closer. This is very similar to a problem we could have started with, but now it's got some ugly numbers. But what I'm going to do is I'm going to set this equal to 0. So I'm going to subtract 330 on both sides. So now it is just set equal to 0. And when I have, and this will help you, right? When you get a question like this on the review or the test or your homework or whatever, things should work out nicely, right? We should be able to get a final answer that groups nicely. I have 4 terms, I have a cubic here, so I'm going to go ahead and factor this by grouping. I need to find the GCF for both the beginning and the end there. So my GCF up front is 169 x squared. And my GCF for the back is 165. Which works out nicely, right? I need those factor pairs to match exactly. questions? Doing okay? Let me see if I can get rid of my picture here. I have a little bit more space. So I have my first factor, which is x minus 2, and then I've got the rest of my factor. So that is it, all nicely factored. I cannot factor this any further, right? There's a plus sign there. These are not perfect squares, so I'm done, which means I can set my factor equal to 0 and solve. So I get my answer. The answer is x is equal to 2 yards. Now we've got this other factor to work with, but what happens with this factor if I set it equal to 0 and solve?
You're gonna have to get a square root, and then you're gonna get an imaginary number.
I'm going to get an imaginary number. Let's double check to make sure we see it. So I have plus 165 equals 0. So I get 129x squared equals negative 165 over 169. Which, right, at this point, if I take the square root of both sides, I will get imaginary solutions. So you can go ahead and throw out this solution as imaginary, and this is what I mean by you should get kind of a nice round answer, right? We should get a nice numbered answer that matches up with the solution up here. And if I wanted to check my work, I plug in 2 for all of these things. I multiply those things together, length and width and height, and I better get 330 cubic yards for the volume. It is not homework time yet, sorry to say. I know this has been a long class. You have a matching activity first. You are free to work on this with someone else if you would like. You need to check your answers with me before you can move on to the 6.3 homework worksheet. This is usually like a scavenger hunt activity that I just put on a worksheet this time around. If you do not get this done now, it will become homework. I know. Always homework.
I'll turn
Hey-ho.
You want to split it at 8 then?